And my best regards to Dr. P.S. Chawla, Dr. Agarwal, Dr. P.P. S. Arora, Sri Shailen Shukla, and the coordinating professors, Professor Aditya Singh, Professor P.P. Rajput, Professor Vivek Singh Rathod, and other distinguished speakers and guests. So, good morning to all my friends, and wishing you all happiness and peace on the occasion of Vinayak Chaturdashi. So, let me just introduce myself. I am Saikat Paul. I am working as an associate professor in the Department of Architecture and Regional Planning at IIT Kharagpur. I did my graduation from GEC Raipur and did my post-graduation in city planning from IIT Kharagpur, post-graduation as well as PhD. I was a recipient of Gates Scholarship and Fulbright Fellowship and was a visiting researcher at Cornell University, Ithaca, in US. I served in ISRO for quite some time, and I have been working in the field of GIS and remote sensing. My research interests include architectural design and visualization, morphometric analysis, disaster mitigation and management, studying impacts of human interventions on ecology and environment, building energy modeling and sustainable development, urban heat island studies. So these are some of my interests. Okay. So today we will just take a look. I mean, this is a very broad area of research, very broad area of work. There are various components to implementing smart city mission, and it is one of the hot areas. This is one of the frontier areas where people are working these days, and this area basically encompasses a lot of different technologies. I think I am the last presenter, so you would have been appraised by now regarding what all technologies are involved to make smart cities. So smart cities, basically, there are a lot of technologies involved really to make a city smart and sustainable. So I shall be speaking on the spatial computing part. I cannot get into too much of details because this itself is a huge body of work and probably would cover a kind of a course in a university program. So this includes wide ranges of technologies included. And I shall be talking about very briefly about these different techniques and methods and technologies which are involved in making our cities smart with the, a framework within a framework of spatial computing. So my presentation would have a brief coverage on how, cities could be smart, what is our thought process, and how human beings have been interacting with their environment to really make it smart and sustainable. I will talk about the smart city geospatial model. We will also look into the definitions of the smart cities, which has been given by different authors at different point in time. So it would also give us some kind of an inkling into what a smart city really is and how your geospatial modeling can help in designing a smart city. Okay, we shall also look into the smart city system, the various facets of it, in what way a city could be made smart. I think some of the speakers would have already discussed about it in details on some of the facets. So we would be revisiting some of these facets. We would also look into the applicability of this particular concept in the background of Indian city planning. Okay, so we have been trying to make our cities smart. We have a Government of India initiative. It is one of the mission projects of Government of India, the Smart City Mission Project, under which several nodes have been designed, and it has been taken up to be designed as smart, as part of the smart city. And then we'll look into some of the case studies. So, to start this presentation, I would like to quote Jan Gell. He says that we shape cities, and in return, the cities also shape us. So it is not a one-way interaction that we have. We are basically shaped by our environment, and we also contribute towards shaping our environment. So what it goes to say that this concept of smart city and how this saying is so apt in this context is that when we are talking about smart cities, it is not a kind of a formula which can be implemented in each and every context. You know, so it is very contextual idea. It has wide applicability in different contexts, in different context of cities which are located in different geographic regions or countries, having very different type of requirements. So it is a continuous your evolving framework. This framework basically is evolving in a very continuous manner. So we also need to include our technologies, design infrastructure to meet these challenges, this continuous requirements that we have for the smart city mission. So I had already talked about the contents of my presentation today. Now, talking about brief history, human beings are intelligent. I mean, they are one of the most intelligent creatures that we have on this planet. So we see that in the process of evolution, which of over almost 40,000 years ago, there were aboriginal people. I mean, they built their settlements. I mean, from nomadic culture, when they started settling down, they started practicing agriculture, and they started developing smart and sensitive relationship with their nature and the surrounding environment. So it just goes to say a small example, to quote a small example, that they made a kind of a symbiotic relationship with killer whales. You know, these are one of the most dreaded creatures. So they made a symbiotic relationship with the killer whales to jointly hunt for fishes. I mean, it is required for sustenance of human being. So what people would do is, after catching the fish, this Aboriginal people, I mean, almost like 40,000 years ago, after catching the fish, they would, give some of the share of this catch to the killer whales. So what happened is a symbiotic relationship developed, and this killer whales would drive the fish catch into the Aboriginal settlements. Okay. So this mutual beneficial model, it helped both, the people as well as the, whales, the creatures which were also, banking upon the fish catch as a mechanism for their survival. So this mechanism was mutually beneficial. I mean, there was a synergy between the man and the immediate ecology and the environment. So, but this model ended in in one moment. I mean, there were English settlers. They shot a killer whale. Okay, they invented a gun and shot a killer whale. So that moment, this synergy, this interdependence, this cyclic, your ecological balance was broken because these whales never returned back. And as a result, what happened was these people, they were deprived of the fish catch, and also it was not beneficial for the whales. Now, this reminds me about one of the incidents that I recently experienced when we visited a coastal town in West Bengal called Digha. So recently there was a cyclone. It caused a lot of agony and pain and destruction in this particular region called Digha and Shankarpur, Mandarmani, and this entire coastal tract of West Bengal. So we witnessed the carnage and the demolition of this particular cyclone. You wouldn't believe that the sea walls, embankments, dikes, which were designed to protect the coastal belt, the villages and these cities, were thrown almost like 10-20 meters inside the inland. Some of the trees were knocked down. So there was humongous amount of energy which basically impacted the human settlements. Now, while talking to the different stakeholders, we started talking to the fishermen regarding the impact. So when we started talking to the smaller fishermen, what they said was nowadays there are big trawlers which are going out into the sea for fishing. Now these trawlers, while they are casting their net, they are casting and dragging it at the ocean floor. Basically, this ocean floor is the place where the next generation of fishes, larvae, spawns, the eggs, basically they hatch. So when they are skimming the sea floor, uh, uh, I will just like to take a break. I need a break for 2 minutes. I have an important call to attend. I'll just get back.
सैकत जी आपकी आवाज नहीं आ रही है.
Sir, actually, I got a call from our head, so
Okay.
it was important. So I'm sorry for this interruption.
No problem, no problem.
Okay. So basically, this our actions, it is impeding the environment and ecology, and our practices are not really sustainable. So whenever we intend to do something for say commercial exploitation or the benefit and sustenance of human beings, it is also important that we look into the different dimensions whether our practices are sustainable or not. Okay. So there is a very interesting book called Dark Emu. It is titled Dark Emu, and it is written by Bruce Pascoe. So, if you can get a copy of it, it will be a very interesting read. During your free time, you can read this interesting book, which highlights the relationship of these kind of symbiotic relationships that we have with nature and how we are destroying it. So, your Lewis Mumford, he was one of the American philosophers and an architectural critic. He talked about the geographic plexus, which is an economic organization or an institutional process, theater of social action and an aesthetic symbol of collective unity. So he talked about this interactive model and also talking about the globalization of these thoughts or impacts of urbanization. So, we talk about two words these days, which is local and global or glocal. Huh. So, one is global, one is local, and these two interact to give you the word local, by which we mean to say that there is an impact of the local, interactions or your interventions, and it has global implications. So it is basically seen, the impacts are felt, and the IPCC has different your predictions, the global predictions for climate change and impending, temperature rise. So we are feeling this kind of effects. You see the climatic patterns are distorted, the intensity of cyclones, uh, your the intensity of cyclones and storms, they have increased. The frequency has increased. So we have to basically cap our emissions. We have to, see that we do not disturb the ecology and environment, because it not only disturbs us in the local context, but it also has global ramifications. Okay, so we see different, initiatives. All the countries, they have come together for the Sustainable Development Initiative, which is known as the SDG, the Sustainable Development Goals. So we all are working towards a global economy, interconnected, digitally integrated, global, ecosystem. So our thinking, our process of design, the way we are used to, designing our cities, has also undergone a paradigm shift because of this globalization. So nowadays, you will see that during this, period of COVID, uh, the industries are functioning. Our software industries, your employees are working from different cities altogether. I mean, they are sitting at home and working from home. So they are contributing towards the economy. I mean, the economy is resilient enough to withstand this kind of threat, which otherwise, say 20 years back or say 30 years back, would was unthinkable basically. So these technologies are evolving. So it leads to better resilience, better sustainability, if we can link all the different processes, all the different events, and keep everybody informed about all these things. So you're in this context, the smart computing technology is the backbone. It is the major infrastructure, and it has different infrastructure as well as service components. So which your includes, as all of you are aware of, one is the most important is the city administration, which takes the lead role in formulating the programs for development, uh, formulating bylaws, guidelines, how development should go in the city. Then education and research, which also is one of the important components. We have the healthcare, public safety, the real estate, how the development should happen, which areas should develop first, what should be the order of development, what should be the nature of development. So that is basically taken care of by the city administration, and it is implemented by the real estate developers. Transportation, basically, it is the lifeline. I mean, it is the artery or the entire circulatory system of the cities. So transportation plays a major role, and we have been focusing on different types of technologies. So we have seen the evolution of ideas and the need for transportation from, say, very sparsely developed American cities, wherein a personalized mode of transportation was one of the most important requirement. But slowly we realized that, these are energy intensive means of commutation, leads to a lot of emission. So it is better that if we can fall back on public modes of transport. So you have concepts like TOD, that is transport oriented development of cities, being propounded. So a prime example of this is a city like Tokyo, and similarly, our Indian cities are catching up now. We have extensive metro rail network in Delhi, in Bombay, Calcutta, Chennai, and it is being implemented in all the major cities in India as well as the world. So we have seen a shift from personalized mode of transportation to public transportation. Now, with time, we are also seeing an evolution of different type of transportation systems in terms of technology, that we are trying to create e-vehicles. Electrical driven vehicles instead of vehicles which are, banking upon, say, petroleum resources. So our focus, ongoing and future focus, is going to be on electric vehicles, and in that we are looking towards, researching different avenues. Hydrogen fuel cells, your lithium ion cells. So there are various competing technologies which are, trying to provide a solution. And so in this case, you see that we have talked about education being one of the important components. So how it contributes to this entire thing, scheme of, the evolution of technology and others, wherein it plays a major role. Now, we also need to have utilities which are intelligent, and all these needs to be interconnected, and there should be efficiency in operation. So, I had to mail some transcripts, your scores of, say, 12th and other mark sheets to one of the colleges for my daughter yesterday, and I had to wait in the post office counter for 45 minutes. So that goes to show that our system is not efficient. We need to find some solution to make it really efficient. So that is also being researched, and we are trying to see how we can convert or increase the efficiency of our system. Another problem which stares us is increasing urban population, which is slated to grow to by about 2.5 billion in the next 30 years. Okay, so it is going to create an enormous demand, additional demand for new infrastructure, such as housing, transportation. So it is going to create an enormous stress on the existing infrastructure. And on top of it, it is going to be compounded with the climate change that we are witnessing. So I was talking to you about e-vehicles, electrically driven vehicles, to reduce this emission. But again, we have to see that the energy that we generate is from sustainable sources such as solar energy or wind energy, or say piezo energy, or energy sourced from wave action, ocean wave action. So if we still bank upon getting energy from, say, coal, which is thermal power generation, which is the major backbone of power generation in our country, we are again to accelerate the process of this climate change. So we have to fall back on alternate methods. We have to look for alternate ways of, commuting in the new normal, in this case of COVID. So with this increasing pressure of population, urban pressure, and the stress on your infrastructure, we see that while we are driving vehicles, due to our follies, maybe we are inattentive or tired while we are driving, it is leading to a lot of accidents. So, autonomous vehicles are one such another innovation which is taking place, and you would have seen that in the decades of 2000 or 2010, there were competitions being held in universities for designing of autonomous vehicles. And now it has come to the commercial front. Now you have Amazon, Ola, Mercedes, and other leading companies which are trying to come up with your commercial solutions. I mean, on-road solutions of autonomous vehicles. So it will basically create the next generation of vehicles. You will see that some of the vehicles already that we have in our, which is available in India, have some of these kind of technologies built into them, that they can follow a lane. They have the technologies to follow a lane. They won't deviate from the lane if you lock it. You can identify if the vehicle leading you is going to brake or it is braking. So your vehicle also automatically comes to a halt if there is a sudden, a person suddenly comes up in front of you. So all these technologies are, slowly permeating into our daily life. So from research, from academics, from research into practical systems and technologies, we are seeing this kind of development in these technologies and permeation of these technologies into our daily life. So for city management, also we need to look into the different technologies and techniques which can give us very smart solutions, wherein we can cut on the waiting time. We can reduce our waiting time to get the services, make ourselves more productive. We can increase our GDP. We can be more productive, and we can contribute more to the growth of the nation with since we have more time. Cities become more efficient, so the energy required would be much less to really pursue a task. And this aligns with the vision of UN 17 goals for ensuring sustainable food, water systems, and energy, and access to, say, education and healthy communities. So these are some of the things that are important for us. And when we are talking about this infrastructure, it refers to the physical as well as the organizational infrastructure. One is you need to have sensors, and another component of is the organizational structure. Who should be regulating it? Who should be taking, conscious decisions based on the inputs that we get from these sensors and the physical infrastructure. So there are three perspectives of infrastructure that we have looked into. One given by Ramaswamy. It is available in the literature. One was given by IEEE Conference on Smart Cities in 2018, and another, which is the National Level Presidential Policy Directive 2021 under President Obama. So they have identified about 16 critical sectors, and say 14 of them they depend on the GPS technologies. So I hope all of you are aware of the GPS technology. What is the GPS technology? I think if we do not interact, the session becomes very dull and boring. So I would like to hear from some of you if you have heard about GPS and what do we mean by GPS. Yes, sir. Any one of you, can you please respond? And meanwhile, I'll get a sip of water. So I would like your response regarding what is a GPS. Okay. So GPS, it's an acronym for Global Positioning System, and we have GPS embedded in all our phones. The phones that we carry, smartphones, this GPS technology is embedded in the smartphones. So it is also embedded in different sensors that we use for data collection. So you see the different sectors, that is your transportation, food, agriculture, wherein we talk about precision agriculture and food security these days, energy management, water, healthcare, public health systems, waste and sanitation, waste management, especially your solid waste collection, optimum functioning of your building so that you get a comfortable environment, your green and public spaces, the defense industry, emergency services, your financial services, governance, information technology, law, nuclear, energy, and your deterrence, safety and security, education system, sector, chemical, commercial sector, manufacturing, private sector, dams. So in all these sectors, you would see that the GPS systems are embedded in functioning of all these sectors. So that is why we are talking about the geospatial model for the smart city initiative. Okay. Sorry. Now, initially the smart cities were also called as wired city, but this term, that wired city, it lost its meaning in the era of wireless communication technology. Nowadays, we are communicating through wireless technology. Not only communicating, we are also charging our devices using this wireless technology now. There are cars in which you just have to place your mobile phone to get it charged. You don't have to connect it to a port, charging port. So we are in the era of wireless technology and mostly the communication technology. So we also give some other names to this wireless communication technology, such as in the context of cities, smart cities, we call them digital cities, or intelligent cities, or ubiquitous cities, hybrid cities, or even information cities. So these are the some of the names which are given to the smart cities. If you scan through literature, you will come across through the different nomenclature of the smart city initiative, and they have been named differently through the process of evolution. Now, the people-centric smart cities, we call them creative cities, or learning cities, human cities, and the knowledge cities. Okay. And the difficulty of explaining these terms, it created a situation that these terms have become unpopular. Okay. So that is why, instead of having so many dissimilar names and trying to justify and basically give them the context, we have coined a smart city which basically encapsulates all the different ideas that we have been talking about. Now, the smart city, your subsequently replace these terms were replaced by your smart city, and it is considered as a strategic development of a city which emerges out of a SWOT analysis. That is, we analyze the strength, weakness, opportunities, and threats of a city, and we have a smart approach towards, evolving the city in a proper direction and giving the right context and direction. We do a smart your SWOT analysis. So for technologists, this has different meanings for different set of people. So for technologies, basically it implies automatic computing principles, or technologies or methods like your artificial intelligence, big data analytics, self-organization, self-healing, self-protection, self-optimization. So these are some of the important 6 components of smart city. Okay. Now, the self-awareness is derived when we successfully, combine this digital city with Internet of Things. Hmm. We have the cloud computing techniques, ICT and IoT technologies. So when we amalgamate it with your geospatial and sensor technologies, and link it through wireless communication systems such as Wi-Fi and Bluetooth and cloud computing. So in the real world context, we create a smart city. Okay. So, these are basically, governed with the backend system, which is known as SCADA. I think some of you would be aware of this term called SCADA, which is extensively used in the industry. They have a SCADA system. Basically, it gives you the health and management, health appraisal and management of industrial system, of how it functions. So it has different components of PLCs and a backend SCADA system. So PLCs basically acquire the data and it transmits the data to the SCADA, which analyzes, and also it can take automated decisions. Okay, you can have manual override. So human beings, they can override the decision taken by the system, or it could be an autonomous functioning system based on the your IoT or say PLC parameters measured by different equipments in different locations. So why we are calling it the geospatial model? Because we are tagging the locational attribute, we are tagging the latitude and the longitude information with what is happening and how it is happening at a given location. And so we can take a corrective decision. For an example, we may have a drainage problem. So recently we had a flooding issue in Mumbai. You would have come through it in your news channels. Your entire Mumbai was held hostage to flooding. The city infrastructure was dysfunctional for almost 2 to 3 days. The suburban railway corridor was not functioning. Your most of the roads, they were inundated, and shops were closed. So there, entire infrastructure of the city was in disarray. It was rendered non-functional. So we can identify, if we have sensors, we can identify the critical areas wherein which are the choke points in the drainage, so that we can drain out this water, we can monitor the sea level, and how we can create retention and detention basins, how we can clean up our drainage networks, we can regulate the flow, and we can do proper management of these drainage channels and the detention and retention basins, so that we do not have this kind of problems, recurring problems every year. Okay, so this is not a one-off event. This is happening in Chennai. This is happening in Calcutta. This has even happened in a city like Delhi, which does not have so much of rainfall. So what we mean to say is we can do a geospatial analysis of where the problem lies, and we can take corrective decision. So I don't have really got the time to really give you say case studies or take you through the theory behind it, because we have really little time to look into this particular topic, and it's a huge topic that I told you. So talking about the definitions of the smart city, you have several definitions which talk about the different components. One is the smart computational framework or technologies. The infrastructure components that we have already, some of that we have already talked about. and the service components. So we have talked about administration, education, health, safety, transportation. So these are all interconnected through these smart computing technologies, sensors, PLCs, SCADA systems. So we see the whiteboards. It is called a whiteboard application platform, basically wherein you can see the outcome of the analytics. A whiteboard is something like your the driver's panel, which you see in your car. So it gives you the different performances of your vehicle. It gives you the status of how much petrol you have in your vehicle, how many kilometers can your vehicle go further without a refill. You know the speed of your system. You know whether any of the doors in your car are open. So basically, we can create a system, a whiteboard, which can tell us, which can give us a dashboard of the performance of the city, which can give us the different parameters of how and how your different components of the cities are performing, and where are the you can monitor the pressure drop across your water conveyance pipelines. So that might, suggest a leakage somewhere. You can monitor the electrical power grid. So if there is a transformer failure, you can immediately see that getting reflected in your loading performance of the different zones of the city. So you know that there is a problem. So similarly, we can implement into different kinds of segments of monitoring the city. It could be related to the your safety and security. So nowadays, you can do a web scraping from your Twitter, Facebook, and all these kind of platforms, or your news articles and all. So you can identify from which location is a person is giving this kind of feedback, and you can put it as a marker in a map of a city. So if there is a security problem, uh, I mean, somebody, a lady, say suppose in the night she encounters some kind of a problem, she can just put a Twitter message or some kind of a message or a SOS, which can get reflected, and an immediate action can be taken by the administration or the security services to look into this, and we can create a hotspot map of criminal activities in the city. So that is to talk about the social side of it. So we need to make our city smarter by making it more efficient, more resilient, more equitable, more livable. We need to see that the services that we have in the city are equally accessible to the different sections of the people. It could be the social segments, it could be people belonging to different economic segment. So we need to see that we try to give equitable access, and that is why nowadays we have different kinds of indices, such as livability indices, your happiness indices, and other indices, which gives us an idea regarding which are the sections or regions which are not having equitable access to these kind of resources. So that is one such area where we can implement or apply these kind of concepts and ideas. Now, another definition is that a city that monitors, integrates, and conditions of all its infrastructure, such as your transportation infrastructure, communication, water, power, etc. And it integrates together so that you can do proper maintenance, you can monitor the security, and you can maximize the services to the citizens, are also some of the definitions which comes under the domain of your smart city mission. Now, some other definitions we'll quickly go through it, and we will go ahead. Are instrumented, interconnected, intelligent cities which can capture and integrate the real live world data. So we talked about the a decision framework, kind of a dashboard, a whiteboard, in which you get the information from all these sensors through a wireless, framework. You may also have kiosks, meters, personal devices. Even nowadays, you will see live web cameras, which are used for security, surveillance, and monitoring. So there are a lot of web cameras which are available in the open domain. You can see the web, feed of these web cameras. So, they are used by surveillance authorities to check how, if there is any perceived security threat. You can also take decisions based on them. There are ways to basically read your vehicle number to a camera. Your vehicle number can be automatically read. If somebody is speeding, so he can be given a speeding ticket. If there is a vehicle malfunction, so your vehicle has a GPS device built in, and it transmits the health of your system to a person or a institution which is giving you this kind of management services, which is providing you with the services of, say, roadside assistance. So they get to know how your vehicle is performing, or if your vehicle is stuck. So these kind of services can be rendered. So this is not only in the context of transportation, but it can be implemented in several other domains as well. So, when we make the cities better, it improves the culture, the knowledge, what we garner from a city. It motivates the inhabitants. It creates an overall better living environment, a better aesthetic environment for people to flourish and create new things. So there are also definitions which talk about ICT, which strengthens the freedom of speech and access to public information and services. So we have gone through some of the definitions, basically, which gives us the idea regarding what your smart cities are and what they encompass. So, it also talks about conservation of energy, sensitive to environment and natural resources, comfortable mobility, face-to-face communities, so that you can quickly interact within your community and with other communities, and also talking about a vibrant economy. So all these has an implication on the economy. So we have the smart city system. So from a city to transition to a smart city system, we have talked about 6 components. So what are those 6 components? Those 6 components are the smart people, very important, because without smart city, a city cannot be smart. So people who can react to such events which are critical to the functioning of the city. So smart city, people who can adapt to the functioning of the city, who can quickly adapt to smart methods, and technologies, who can also create smart methods and technology and provide a framework or a guideline. So smart people are the most important component. Smart economy. Economy has to be resilient, so it should be able to withstand any sort of stress in a given city. It could be a natural stress, a cyclonic storm, or say earthquake, or it could be man-made event or anything. So like war or something. So we need to have smart economy. We need to have smart mobility, environment, living, and governance. So these are the 6 key pillars or 6 components, most important components of the smart city system. When we are talking about analyzing the performance in a geospatial framework, we need to get inputs from all these 6 systems, and these systems needs to interact with one another. So the prime movers for this capacity to transform cities are the smart people and the smart economy. Without the people and without the economy to support the smart cities, it is going to be a dysfunctional space. So for the city to transit from a city, normal city to a smart city, these we need to invest or improve upon the 6 components. Okay. So though this proposition contradicts the simplified approach of many governments in the developing countries, wherein we just talk about provision of basic services. We do not talk about provision of smart services, but we only talk about provision of basic services. So this is in contradiction to, the smart city program or the mission or the provision is in contradiction to the those initiatives of providing basic infrastructure in the mostly in the by the governments in developing countries. It is because of 2 reasons. We told that smart people and smart economy are the 2 most important components. So it is because of unavailability of your good economic resources, and people are not also well educated to adopt to these kind of measures, that these cities cannot, in the developing countries or third world, they face hindrance in transiting from a city to a smart city. So, we have to depend on multinational companies basically to implement this ICT enabled infrastructure. So, we have to be resilient enough, and we need to have our own people being able to provide this kind of services. So, we have several programs in India, such as Startup Mission, which basically, is a program to create entrepreneurs to, create a bunch of entrepreneurs from our young students and young, or any citizen of this country who has got interesting idea can create a startup and can get into this particular program. He can come up with services or technologies or sensors or platforms. We said we can make whiteboards and your analytical platforms. So they can contribute to any of these different ideas. So they can be part and parcel of this development. Otherwise, we are basically giving away our hard-earned money, hard-earned resources, the GDP of this country, to your multinational companies for implementing these kind of sensors. So students who are into instrumentation and other your branches of your engineering, who are into production management or say systems management and other areas, they can very well contribute to this particular program by developing sensors, systems. Students who are into information technology or computer science, they can very well come up and tie up with, say, urban planners, civil engineers, architects. So they can tie up with all the different components of the thinking process and the research backend to basically come up with interesting systems, solutions for our cities. Now, the smart city, basically, the best part about smart city is that it is an accountable system. It is a responsive system. It is an accountable system. So it provides transparency to the governance. So that one such mission is currently underway, and you know that how many vaccines are available at a given location, and it is available to you at the touch of a button. If you open your web browser, you can find out where is the location of the nearest hospital and how many vaccines are available at a given day. So that is a very, good example of smart governance and making your systems and cities smarter. So how we can innovate and create interesting applications for smart governance, and how we can relate it to the geospatial frameworks, so that you can be given the directions. Even you are new to a given city, you can find out the directions of going to the nearest inoculation or your immunization center. the health center where you can avail your COVID vaccination. So these technologies are available, and these technologies has a equitable reach. I mean, it does not differentiate between a person who is rich and poor. Everybody has got an equitable access to these kind of technologies. So what I mean to say is that these kind of technologies are very transparent, they are accountable, they are responsive, and they also give you a spatial decision support system. So government knows that how many vaccines have been consumed and when do they need to place order for a new batch of vaccines. So from time to time you will get to hear in the news that government has ordered so many crores of vaccine. So we know what is the stock and how at what rate the vaccination drive is processing, how much percentage of the people are getting vaccinated. So this is to just give you an example, an idea regarding how a smart system can be implemented in a real time mode, in a real time mode, which is accountable, which is responsive, and which is a transparent system. So this kind of setups or systems, they can give you, access to your public services in a very efficient and effective manner, in a very cost efficient and effective manner, and it has a wide outreach. You can't imagine how this vaccination program has been reaching out to villages and far-flung areas. How successful this program has been. So, we talk about the triple helix model, in which your governance, academia, and business, or industry, they have, your competing roles, or you can say, synergic roles to play in this smart governance program. So when we are talking about governance, we are talking about the government, academia, and industry. Okay, wherein we are having the financing, policy formulation, innovation support, and advisory services. And we also have the academia, wherein we have the incubators, spin-off, the R&D sector, and the industry, wherein we have the entrepreneurial or product and service development, which is the component from the R&D which comes into picture. Okay, so we have this triple helix model. They are interactive in a way that they are interacting with each other. So, this model basically looks into the governance aspect. So, when we try to convert the environment to smart environment, we have the different components, like your information acquisition and dissemination using smart sensors and networks. And we have processing platforms like intelligent devices. We need to have a platform which can basically store and process this data big time, in real time, using data analytics platforms like big data analytics. So we need to have platforms wherein we can get feedback from sensors, like your PLCs and SCADA systems. We have the predictive and decision making capabilities using your whiteboard applications. So we can have in the when we are talking about the smart city network, we are talking about metering. Okay, we know the consumption of your different resources such as energy, water, or other services. So we talk about metering, or we talk about creating energetic face-to-face communities, So we can do a smart metering using IC, CT, RTC, relay meter, calibration metering communication. You and having outage detection. We can have advanced metering systems to say to see what is the balance between your uh, the production of energy and consumption basically, and the load distribution. So we also talk about the gateway and the protocols, like you have IP addresses, you have ZigBee, ZigWave. So these are some of the frameworks, PLCs. These are killer applications. These are some of the frameworks, like you have IP for your internet connected devices. So similarly, in the smart frameworks, you have ZigBee, ZigWave, PLC. These are some of the protocols which are used for gateway device profile controls. Now we have the smart metering platforms that we have talked about, and the smart servers, that is the MDMS platforms, that is the metering data management system, and also billing system. So we can create a smart environment based on this particular framework, which is geospatial. So you can know if there is a power outage or say load imbalance, why is it happening, and how do you need to balance the load in a given city. You can also look for cogeneration. So smart environment is one of the areas which generates data for environmental management. And only a well-trained smart community can use the data generated to make appropriate decision as per the current issue faced by the user population. So if we see this figure, if we see the data architecture, we see that initially at the interface between the urban system and the smart environment, we have an interface, a web of sensors which spreads across the city, which feeds data into the central control console. It is the your big data platform wherein the your sensors basically feed their data. So at the control center, the data is processed by smart applications which are based on either artificial intelligence or your data analytics platforms. So they are analyzed, the trends are analyzed with existing trends, or your trained decision support systems to basically extract meaningful trends and information. And these are used in the third stage for decision making. So this decision making could be your automated, or it could be in a manual mode, and we can integrate that using various devices having different types of technologies. So you would come across different communication systems. Mostly broadband communication systems are put in place. So you can see the architecture of environmental resources, and the same your six system model can be applied to the environment. The six system model that we had talked about can be applied to the environment. So in this figure 4, it can be achieved by any environmental resource which needs environmental resource governance and management. So you can say, if we take the water environment, so if generic environment is substituted by water resource or urban flood, we can include those six systems that we had talked about for water resource management and urban flood management issues. So the design and protocol of the six elements of the system, it needs to be developed from the 3 point of views, most importantly, that are in the second layer that you have in this particular image, that is the ICT or the IoT system, Internet of Things system, or e-democracy. The second is the e-democracy system, and third is the e-governance practice. So these three points, or the six elements needs to interact with these three basic concepts or protocols, the ICT, IoT, e-democracy practices and e-governance practices, to integrate it finally into a governance system for, say, water management system. So this has been used for KMA and protocol for water management practice by the smart communities. Now, when we are talking about the smart environment, it is the second building block, and it has these attributes like the smart city basically protects and it has a synergy with nature. It protects nature. It is attractive. It is aesthetic. It values the natural heritage and the resources. It capitalizes on the scenic resources. So it would basically try to find out the most beautiful parts of the city and basically integrate it with recreation and other activities. It conserves and preserves the ecological system. It basically integrates the system with different your resources such as water supply system or waste management systems, drainage systems, or say electrical systems. So, it looks into the integrated management from the sustainable perspective, so that it is climate responsive. You can minimize your emission from a given city. Now, we also have the smart city, which embraces biodiversity in a given region. So, biodiversity, as you know, is a very important concept when we are talking about ecology. That we need to preserve and maintain the aboriginal species in a given location or a given city. So what we try and do is we try to plant all, your biological species, especially your, say, biological or zoological species. So they may be invasive in nature. So if we plant these kind of plants, it will basically not allow the aboriginal species or the resident species of a given location. It will create a different kind of ecosystem, an alien ecosystem. So we need to see that we preserve the biodiversity of the city region. So in cities, you would see the forests are dwindling. The canopy of the trees are basically cut down. In a indiscriminate manner. So we need to look into these kind of issues. And you know that these, if you cut down on trees in the cities, it will have a bearing on the microclimate. The ambient temperature will go up. It will have a bearing on the energy consumption, and your electricity bills will start increasing because you have to fall back on air conditioning systems to cool your houses. So, and that waste heat is basically again given off into the city, and the ambient temperature increases further. So, these kind of systems are not really, sustainable. So we need to create, protect the biodiversity, and the smart environment should look into protecting the biodiversity of the region. And also we need to, see how we can accommodate your nature and ecology into our urban areas. Now, we also need to have the, a smart city would also efficiently and effectively manage the natural resource base. So these are some of the attributes of smart environment. Now, the second component of the smart city, third component, we have talked about smart governance. First, we have talked about smart environment. So let us talk about smart mobility. So you would have already come across this term called smart mobility. So it is the third building block of a smart city system. It includes features such as mobility of people, and not just the vehicles, but also of people. So when we are talking about mobility of people, so it should include walkability and cycling. So the city should have walking tracks, jogging tracks, or cycling tracks. It should have vibrant city at streets at no additional cost. It should manage vehicular and pedestrian traffic and traffic congestion. It should have pleasurable routes so that when you go out, you feel relaxed and not stressed. So you should also be able to have balanced transportation options, because we know that transportation options has to be inclusive. We have to make it accessible to all different sections of society, be it economic sections or any other section of the society. So it should have different price bands. So it should have to be accessible to different, economic classes of people. So we are talking about mass transit, rapid transit system, MRTS corridors, such as metro rail, light metro, monorails, sky train for high-speed mobility. So these are some of the different components. Then we have integrated high mobility systems like linking of residential areas to workplaces, recreational areas, and transportation nodes. So we may have multimodal hubs, like a hub which wherein you may see that it is connected to the airport, it is connected to the metro services, it is connected to the road transportation services, both local as well as regional transportation. So we can, plan for smart city initiative which have integrated high mobility systems. So it should also have your seamless, mobility options, and it should have uniform availability so that people across the entire city should have access to these smart mobility measures. So we have talked about smart governance, we have talked about smart environment, we have talked about smart mobility. Now let us talk about smart people. So smart people, basically they excel in whatever they do. It could be professionally, it could be in their own personal community sphere. So your the community is converted into a functional community. So where there is exchange of ideas, resources, economic interactions. So that basically makes for a smart society, a smart city, if you can have smart people. So what happens? I mean, if you have smart people, it will result in high human development index. We were talking about development index, livability index, happiness index, and all these kind of different types of indices which have been developed, which have been put forward to gauge how your cities perform, or how different countries are performing or regions are performing. So it would result, if we have smart people, it would result in a high human development index. Now, it would interact or integrate different sections of the people who can provide interesting ideas, like youngsters in colleges, like professors, or say, researchers in different research establishments. So it gives us a platform to network all these smart people so that they can come up with interesting ideas. So it basically looks into, linking together high human capital, people who are knowledge workers. It links them together, so those ideas can be put forth together. That can be brought together to create an interesting platform for governance, mobility, good environment, environment, etc. in a smart city context. So, we have talked about the different components of the smart city. We also see that the smart people who are components of the smart city are highly flexible, and they can really absorb the different technologies, the new technologies which are coming up. So, and they can adapt to the changing circumstances. So after we talk about the smart city, we talk about the smart living. So, we have all common values. So we have common and shared values, strong common and shared values. So when we bring it together, we have a thriving city where we can help each other, we can celebrate our success, we can help each other during our troubled times. We can come forward to take up very huge tasks which is not possible to take up individually, and we can have a vibrant city which works 24 hours a week, 7 days, 24 hours a day and 7 days a week. Okay. So it is safer, it provides better quality of life, it is more accessible and has quality open spaces. It provides you with peace, happiness. It has, you can, it meets the aspirations of the community. It promotes art, culture, it promotes the heritage of the city. It permeates that to the newer generation of younger kids and children who, take this kind of, heritage with them. They have these values within them. So this is all about the smart living that we come across in the smart city. So it basically would enrich and improve the aesthetics and the conditions of the city. Talking about the smart economy, we said for to have a smart city, the two most important components are the smart city, smart people, and the smart economy. So without these two, it is really difficult to have a smart city. So a smart city or smart economy would generally understand what is the DNA of the city, what is the economic framework, how it works. Is it a retail city? Is it a city which is educational city which thrives on the health infrastructure, so that it is a tourist health tourism, it promotes health tourism, whether it is a retail center, whether it is a manufacturing hub. So basically a smart city understands the DNA of the city, economic DNA of the city, and it can provide solutions. So these solutions could be creative. It could provide a platform which gives rise to entrepreneur leadership. It would encourage youngsters to come up with interesting ideas and challenge them to open up your institutions and industrial establishments, economic establishments, so they can be job providers rather than job seekers. It gives rise to, more opportunities of, contribution of different sets of people who have that kind of knowledge base, and they can be brought into the mainstream of the city. So it creates, better economy. It creates better, the, contribution in terms of the gross domestic product of that particular city. Okay, so it looks into the different sectors. It is a smart economy will also make it globally competitive. So these are some of the components of smart city, and we have looked into some of the very important components and how they contribute. Now, let us see in the geospatial framework, how do these ideas get implemented, and especially in the Indian context. We also see one or two examples from the global context. But first, let us start witnessing some of these ideas, how they have been implemented in the Indian context. I will take your permission to have some water, and I'll get back to you in a moment. Okay, so talking about Chandigarh, Chandigarh, we know it was a result of the City Beautiful movement. It was planned as the capital city of undivided Punjab. It was designed by the famous architect, city planner, architect Charles Edward Jenner, popularly known as your Lee Corbusier. So he based the design of your Chandigarh on the garden city concept. The design was based on the garden city concept, in which he gave the V6, the concept of V6, that is, you have 6 orders of road. Now, we have another 2 orders of road are being added, that is the V7 or the even the V8. So we have your cycle tracks and pedestrian tracks. Okay, we had 6 orders of road. So in addition to that, we have another another 2 levels, that is for the cycling tracks and for the pedestrians. So we have also the green spaces. You can see that there is a central spine, which is a continuous green area, which you traverses through the entire city. Okay, so you see how this city has been planned as a garden city, where the green area, the environment basically permeates into the entire core of the city. So we can see that this applicability of geospatial technologies, which integrates the ICT tools, it includes several sets of technologies. So geospatial technology, it is not a ubiquitous term. It is not just a term in isolation. It relates to the collection and processing of data that is associated with the geographic location. And it is a very broad term and encompasses an amalgamation of technologies. It encompasses different technologies such as your remote sensing, your geographical information system, GIS, your global satellite navigation system, that is GNSS, and popularly it is known as GPS, global positioning system. And we have this prefix geo in all these systems because it alludes to the Greek word which geo, which implies earth, and spatial identifies space. So geo in Greek, it implies earth, and spatial implies space. It identifies with space. So when we are talking geospatial, we are relating the spatial connotation with respect to earth. So the remote sensing is a technology which is concerned with acquisition of images and information and data about an object without directly being into contact with it. GNSS, it provides us the satellite-based geolocation, and it is extensively used in the public domain for navigation. And we have GPS devices linked to public transportation systems. So if you travel to Japan or US, you will see the public transportation systems also will have an application in your mobile. So you can download that application and you would know the location of the next bus which is going to come to your location to pick you up, and you will also know what time it will take to reach your location. So linking all these different technologies that we have been talking about, GIS, remote sensing, GNSS, LBS, photogrammetry, surveying, IoT. So all these technologies can be linked together to provide very smart solutions at your end, which will basically save a lot of time and your energy. So the geospatial technology, it contains georeference data which are procured from surveying and mapping and photogrammetry technique. Now, what is photogrammetry technique? Through photogrammetry, we can derive the locations, the 3D coordinate locations, also the height and the distance information from images. If you have images, from there you can identify the heights and the geo-specific locations using bundle block adjustments, and different mathematical techniques and approaches are there which are used in photogrammetry to basically come up with different sets of maps, like your contour maps, like your city transportation maps, or even like your topographic sheets. Survey of India, you would have heard about this organization called Survey of India. It was once upon a time led by one of the English explorers by the name of George Everest, based on whose name your Mount Everest has been named. So, your Survey of India has been using the photogrammetric methods, analog and the digital photogrammetric methods, to basically identify and create maps of our cities and regions in and around India, in the entire Indian subcontinent, starting from your Pakistan, India, Nepal, Bhutan, Bangladesh, Myanmar, as well as Sri Lanka. So entire region was mapped using this photogrammetric method, and we can get the each and every specific location of a feature, land feature, to its best possible accuracy using this kind of Survey of India maps. So these kind of topo sheet maps are available. So whenever you are doing this kind of projects or developing these platforms or whiteboard applications, dashboard applications for smart city missions, you can always request for these set of maps from Survey of India. They are available in a UTM projection, Universal Transverse Mercator projection. So you can relate this data, you can link this data, you can create platforms which can be used by different sets of users or application generators. So uh, I mean, techniques such as this photogrammetry technique. And we have the convergence of data using this different from these different platforms, using techniques such as Internet of Things or location-based services, LBS. Here you can see one term which is known as LBS, which is known as location-based services. So, we have the different cities wherein these concepts have been applied, such as the utilization of solar energy potential in Jawaharlal Nehru National Solar Mission, JNNSM, for the development of solar cities, solar parks, and ultra mega solar power projects. So we also have other schemes and initiatives such as 300 megawatt of grid connectivity solar power projects by defense establishments. We have grid connected solar PV plants on canal banks and canal tops. 1,000 megawatt of grid connected solar PV power projects by CPSUs and government organizations. We have almost 1,000 megawatt capacity of grid connected solar power projects, which are implemented through NVVN and under the NSM missions. We can also have the viability gap funding scheme, solar generation based initiatives. So these are some of the other initiatives which are the initiatives under the smart city mission for utilizing the solar potential, energy potential in our country. So these are some of the interesting mission projects, and you can, being faculty members, you can also suggest projects to the government of India for, say, electrification of rural areas, or even your college. Also, you can set up the solar power plants in your college. Also, you can have a co-generation plant in your college. So we do have it under the solar mission, national solar mission of government of India. We have, a substantial solar generation program at IIT Kharagpur, wherein we are almost able to generate energy for sustaining our labs, the computer labs. Now we have the different applicability. We have the first model solar city, which is the Gandhinagar. We have talked about Chandigarh. So the next city is Gandhinagar, wherein it is going to be developed as the first model solar city under the Smart City Mission project. So it will have a geographic information system, which is going to be used to generate the building footprints and the solar rooftop potential using the standard solar insolation models. So you can have different insolation models to give you how much of solar potential is there, how much of radiation is incident on a given city. and how much of that incident radiation can be converted into solar energy. So there are mathematical insolation models based on the latitude and the location of the given city. We can model how much of solar generation potential is there in a given city based on the rooftop potential and the building footprints. So we can identify the efficiency of geospatial technology, which has a major role to play in creating this smart energy. Okay, so we have several schemes which are listed out here. I'm not going to read each and every one of it or one of them. So mostly they have been the canal bank projects, the canal top projects, rooftop projects. So these are some of the major projects under this particular mission in the city of Gandhinagar in Gujarat. Second project is the Ahmedabad, third project is the Ahmedabad city of Ahmedabad Gandhinagar smart city project, which talks about automation-based smart environment resource management. So there we have smart grid, we have smart building, and smart environment. So basically, we try to see the synergy of these three, components. So we do monitoring of the critical environmental parameters such as temperature monitoring, humidity, illumination, barometric pressure, vibration and acoustic noise, your air and water quality assessment, safety and city security. So these are basically monitored to see that, how it has a bearing on energy consumption, water consumption, and other utility projects. So this is done in a smart mode. So for Ahmedabad and Gujarat, we have this smart grid, smart building, and the smart environment project. Now we have different technologies, application of different technologies when we are implementing this smart city mission project for the case of Ahmedabad and Gandhinagar. We have different geospatial technologies like your HAN bus. HAN bus stands for Home Area Network, WSN network, that is wireless sensor network, and the IoT, that is the Internet of Things. So wherein your physical devices such as home appliances, vehicles, electronics are basically connected to each other through embedded electronics, sensors, actuators, softwares, and they are connected through wireless technology. Or web-enabled technology, wherein we have WSN, wireless sensor networks, and also HAN, that is a home-based area network, HAN bus. So we have several guides and recommendations. So for these, the new buildings which are to come up in Ahmedabad, Gandhinagar region, so they should be equipped with your smart technologies. It should have your, modern components. Say for illumination, it should bank upon LEDs to reduce the CO2 footprint. So awareness is being spread for these to achieve these mission goals. It should be easy for designers and maintenance staff since it is all linked in a platform. So we have the smart platform. So we have a GUI via the internet, the graphical user interface. So you can see the corridor control, the lawn control, your water tank level, etc., the room control panel. So this is the automation framework, environmental resource management framework, which is based on a geographic spatial region, which continuously monitors the entire city operations. Okay, so this is how it is going to be implemented in Ahmedabad, Gandhinagar region. Now in Kozhikode, we have, under the Smart City Mission project, we have the smart water management, which is again a geospatial application in the metropolitan areas. So we look for smart water communities is based on the ecological conservation and cultural design. It would permeate conservation of water, prevent the waste of water. since it is limited in terms of resource availability. So when we talk about the contribution and applicability in different cities, it basically has governance benefits, that you can govern the cities in a better way. It is more sustainable and manageable. And if we see the case of Surat, when we are talking about the smart city mission, uh, waste management, solid waste management, and environment management has been implemented in Surat using this geospatial smart technologies. So they basically look into the door-to-door waste collection, your e-bus services, integration of agencies, your data collection, mobile-based and your web-based data collection and integration, integration of GNSS and GIS. You have agencies like Surat Urban Development Agency, SUDA, Irrigation Circle, Surat Irrigation Circle, Groundwater Resources Development Corporation, Gujarat Ecological Commission, and Gujarat Industrial Development Commission, which work in synergy to implement this smart city project. Now, we have talked about the examples from Indian cities. Let us look into some of the examples, or a few examples, since we are coming close to this lecture session. I will take up just some few minutes more to talk about this example from the Yokohama Smart City Mission project. So METI, basically this was a project which identified 4 cities in Japan. One was, the Yokohama city in Kanagawa, Keihana city in Kyoto, Tokyo city in Aichi, and Kitakyushu city in Fukuoka. So these are 4 islands, and the cities have been identified to basically operate and practically establish the smart grid technologies. So your METI's Next Generation Energy and Social System Demonstration Initiative for the case of Yokohama City started with this project, which is known as the YSCP, Yokohama Smart City Project. So it is in the world, it is one of the largest scheme of smart city initiative experiment. Okay, so here we talk about the energy management systems, community energy management systems, SEMS, building energy management systems, EMS, factory supervisory control and data acquisition systems, that is FEMS, home energy management system, HEMS, supervisory control and data acquisition, SCADA, electric vehicle energy management system, EV/EMS. So these are the components of this Yokohama Smart City project. Okay, so and similarly, it is going to be established in the other 4 islands also. We talked about Kitakyushu, in Fukuoka, Kaihana, Tokyo City. So these are the 3 other cities which are going to also implement this smart city project in a very large scale. So we can see the technical targets. It was established for the whole YSCP, the Yokohama Smart City Project. These targets have been achieved. These targets were achieved by 2014 by the due date of official completion. And one of the significant component of the project is the demand response for HEMS. We had talked about the home energy management system. So this demand response usually provides, gives an opportunity for consumers to play a significant role in the operation of the electric grid. So they can shift their electricity usage to the off-peak periods, and they are given financial incentives. Say suppose during the daytimes your industries are working, So what you can switch off your lights to reduce your electricity consumption, so that industries have the electricity, can have energy to operate. So during the daytime, the electricity for residential consumption is charged at a higher rate. But during the night time, when the people come back to their homes, then you need to provide electricity for them at a lower cost, so that they can run their day-to-day activities. And then you charge the industries at a higher premium. So what you give incentivize the shifting of a peak in electricity usage between the homes and the industries. So that is what has been done in the Yokohama Smart City mission projects. It has been incentivized. But in the Indian context, we can take it one step further, that we can incentivize cogeneration, that people who are generating solar energy during the peak hours of your functioning of industries can be paid some extra money, or they can be given some free units of electricity. Okay, so these things can be cross incentivized. So with that, I come to the conclusion of my today's presentation. So thanks to all of you for your patient hearing. I share some of the references which has been used. So one of the, your research literature by J. Gupta, wherein he has interviewed the people and the organizations for untapped gigantic potential of rooftop solar projects in India. Second book was a book by T.V. Kumar on smart environment for smart cities, published by Springer. Another book was Smart and Sustainable Cities and Buildings, again by Springer, by Rojema from Switzerland. Zai, Gupta, Shekhar, and Lee, they have published Transforming Smart Cities with Spatial Computing in IEEE, your platform. So these are some of the important references. There are several other references though, which I have omitted out here. For sake of your brevity and your convenience, I have only shared some of the important references. Okay, so I conclude my presentation with a saying from saying by your Swami Vivekananda, and he said that a nation is advanced in proportion to education and intelligence spread among the masses. So we were talking about smart people. So smart people are one of the, is the biggest foundation to the smart city program. If we do not have smart cities, we cannot have, we do not have smart people, we cannot have smart cities. And it is the onus of us teachers to plant these ideas and seed these ideas with our students, so that they can take up these responsibility and challenges to come up with interesting technologies and techniques to make life much easier for people and make our city smarter, more resilient, more sustainable. So with that, thank you to all of you. I wish you all happiness and peace on the occasion of Vinayak Chaturthi. So thank you, everyone. So with that, I conclude my presentation.
Yes, thank you, sir. Thank you so much for this informative session. And you rightly focused on the topic and explained it with great expertise. And now I request the participants to join the discussion. They can ask questions, they can raise their hands, or can post the questions in WhatsApp group.
I think our,
Yes.
our participants would have been tired by now, because or they would have become expert by now to raise questions after so many deliberations and presentations on smart city. And of course, they are also part of our smart city mission. So if you have any question or any queries, which to my limited knowledge, I will try to answer. Yeah, I think Professor
Yes,
Raja is having.
yes, sir. Please,
Hello, sir.
sir, ask your question.
Yeah.
So thank you very much for your suggestions and remarks and knowledge which has been given to us on the basis of smart and sustainable cities with IoT applications. And also we have learned through it. But my question is to you, or query is to you, what kind of smart in terms of sustainable features in the world has been adopted or existing?
Okay, sustainable features, if you see that we have the problem of incumbent global your temperature rise, and with that we are going to face your sea level rise. So it is a major crisis that is going to happen. We are maybe 10 or 20 years away from this kind of a crisis. And as we all are aware, that a significant part of the population, urban population, is residing in the coastal areas, be it in India or elsewhere. I mean, proper forewarning systems, your creation of evacuation shelters mechanisms, road connectivities, your transportation network, resilient transportation networks. So these, I mean, this is just to show you how a small example, how we can basically integrate all these different technologies. Like we have the the predictive framework by your IMD, the Indian Meteorological Department, ISRO, and other organizations, which gives advisory to the state planning board, the district magistrates, and your national disaster mitigation agencies, NDMA and all. So they basically work on these advisories, and these are all smart platforms. I can share with you a work that I did, a small work that I did when I was in ISRO, which was regarding developing a decision modeling framework for the Brahmaputra river basin, the river valley of Brahmaputra in Assam. Because there, every year we see almost 3 to 4 flooding events, starting from Lakhimpur, Barpeta, and several, I mean, so many districts. I think we work for almost 13 districts in the state of Assam. And there, what we used to do is we used to get the satellite data from radar set. It is a microwave sensor, because your optical sensors do not work when you are having cloud conditions. And also during night time, you cannot acquire satellite image data in the optical region because I mean, you do not have light from sun, and secondly, it is covered by clouds. So your microwave data can penetrate through the cloud, and you can work on this frequency in the frequency region of this data, its backscatter and the response in the horizontal and the vertical polarization. So you can analyze this data. You can take this data into a frequency domain and analyze it for the areas which are inundated by water and which are dry land. So we used to do this analysis within 3 to 4 hours. We would process this data. This data would get to us from Canada, because that time they had their remote sensing sensor, the satellite, which was positioned over Assam. Now we also have our sensors, microwave sensor. So those days we used to get the data from Canada. We used to directly download it from the satellite to our center using a direct data satellite feed. We used to convert that into a decision modeling data framework, which can be interpreted by the district magistrate and the NDMA organizations, because they cannot obviously visualize or identify what is going on with the microwave data, with the remote sensing data. So we used to process that data in a real-time mode and upload it in a web-based framework. So people would have an information or they would have a live, information regarding what is the present status. From the scatterometer data, we could generate the height of the water level. We could generate the elevation of the water level, and with hydrological flood modeling softwares, we could generate the flooding scenarios. And you also know the sections of your say the drainage channels, the major river channels and all. So you know what would be the retention time of the water if the level of water lowers in the river. How much time would be required for those areas for the water to drain out, and what kind of your measures would be required. Now, once you prepare a flood map, disaster map, you can also find out, superimpose on the population data. So you can create a geospatial data, a population data. You can superimpose your flood management data on the population information to know whether those people, you can know what is their, access to vehicles, whether they own vehicles, whether they are from the middle income group or the lower middle income group, or the economically weaker section of the society. So you know how you have to prioritize your evacuation programs. You can identify in sense from the census of India, you can identify the number of population below the 6 years, who are below 6 years, and people who are above, say, 60 years or 65 years. So we had such kind of data to know that which are the regions wherein elderly people might be there, which are the locations of the your disaster shelters, which are the major roads which are navigable or which are motorable, so that we can evacuate those population by those roads. We got in touch with all the your hospitals were within the networks, or the schools were within the network. So the school infrastructure was used as a makeshift disaster shelter. So this is to say a smart management framework within our Indian concept. I mean, what we call in our management paradigm as Jugaad technology. So with our the technology that we have in hand, we try to improvise all the resources with our knowledge, with the contribution of different people at different sections of management, be it NGO, be it government establishment, be it political parties, be it the local level, foot soldiers who are working tirelessly to, meet with this kind of challenges, be it the researchers who are sitting at ISRO and other places processing this kind of infrastructure. So this is a kind of a smart framework, a synergistic framework, which can be used in real time to really come up with very interesting and smart solutions. And you can, see the results of these technologies, that earlier, whenever we had your cyclones or such kind of events, the casualties would be huge. You would see, you can scan the say Times of India or Hindu or Indian Express reports, that how many people would have died or lost their lives because of these cyclonic storms, which has reduced to single figure or double digit numbers in the present times. That we are able to give advisories. INCOIS is one such organization which gives as advisories to the fishermen going out into the sea. So they give advisories to the fishermen going out to the sea to not venture into the sea because of the inclement weather. So these are some of the wonderful platforms that we have already created. And India is one of the leading, one of the leading countries, and it is showing or leading way in the South Asian region, which includes advanced countries like Australia. So India is assuming the leading roles in providing such smart technology, smart initiatives, and we can really do it. We have the manpower, we have the brain, and we have people who can develop all these kind of technologies. So I think this is some of the real life, solutions which I have worked on. I was fortunate enough to work on these kind of problems. I mean, that is to share my experience with you.
Oh, thank you, sir. Thank you. No, because sir, actually, when you are given the example of Chandigarh as well as Japan's that city, so
Yes.
what is means, because in India there are so many issues are there, natural calamities in terms of floods, in terms of earthquakes, but
Right.
normal issues are also in terms of transportation, congestion, then air pollution. So in terms of sustainability, any kind of smart city in India or abroad,
Right.
is it existing or 50% it is existing? That was my question actually.
See, we talk about smart cities and smart economy. So
Yeah.
economy is a major driver, and you know that our economy, we are still developing, and we do not have so much money to even provide the basic services in most of our cities.
Yeah.
It is, we are still trying to provide solid waste management, potable drinking water. So these are still on our plateau. So we have taken up the smart city initiative only at the pilot level in the cities. So maybe a neighborhood or a small project which is being developed for the cities. So as you said, for mobility, we have some, I mean, projects like in Ahmedabad, you will see a BRTS corridor, a bus rapid system, a transit rapid system corridor. In Surat, we have a waste management system. And I have also highlighted some of the other, examples.
Surat is there. Yeah.
Yeah, so these are some of the examples in the Indian context. We are having these projects in the pilot project. So slowly we are going to increase the scale of this project depending on what we learn from this project. And basically, we also need to implement the cities in our Indian context, as you rightly pointed out, that we have our own set of challenges, because a city in India may not have similar set of problems in, say, New York or say Yokohama or Tokyo in Japan. We have our own problems, our own limitations, our own set of resources, so that the solution also needs to be customized. So in the first set of our projects, we are trying to have a learning experience, and based on this learning experience, we can bring it into a kind of a singular platform that can be implemented for our future cities. It can be implemented for all the different cities. It can be a learning experience for us.
Thank you. Thank you.
Yeah, thank you.
Thank you, sir.
Yeah, thanks.
So we have reached it to the end of this session. Thank you so much for being with us, sir. And I want to thank you for your valuable time and also for sharing your opinion with us. And thank you so much, sir. I extend my generous thanks. Thank you so
Thanks
much.
so much for giving me this
Thank you,
opportunity.
Professor Saikat. Thank you
Thank
very
you, sir.
much.
Thank you,
Thank
sir.
you very much.
Thank you, sir. Okay, so shall we end the meeting?
Yes, sir. You can leave, sir.
Okay, okay. Thank you so much.
Thank you so much, sir. Have a nice day, sir.
Yeah.
So we will start the test at 2 o'clock. So the details of the test will be shared with you at 2 o'clock. And as you know about the certification, there should be 80% of your attendance, and 60% marks you should earn in the test. And you should also fill the feedback form, which will be given in the AICT's portal. So all the three criteria you should fulfill, then only you will earn the certificate. So at 2 o'clock, the test will start. Thank you so much.
Thank you. Thank you.
दो हजार का ही लेना मैं बोला। हाँ।
हाँ, क्योंकि आवाज नहीं आ रही, मैंने ऑन मतलब तेज कर रहे। अच्छा अच्छा, ठीक है।